Welcome to day 2 of ICIIS 2021. We begin the day with a keynote address from other distinguished individuals, Tiong, who received his bachelor's degree, master's degree, and PhD in electrical, electronics, and system engineering from the National University of Malaysia. He is currently a professor in the College of Engineering and also the director of the Institute of Sustainable Energy, Universiti Tenaga Nasional. His research interests include renewable energy, artificial intelligence, data analytics, microcontroller systems, and communication systems. He is also a professional engineer registered with the Board of Engineers, Malaysia. Sir, this invitation is to you to deliver the keynote address.
Thank you. So, thank you very much for giving this opportunity to me to share my keynote address in your distinguished conference. Let me share my slide. You all see my slide now? Is it okay?
Yes, sir, we can see.
Okay, good. So, okay, I'm Tiong from Universiti Tenaga Malaysia, and currently I'm the director of Institute of Sustainable Energy in my university. A little bit background of my university. My university is a university wholly owned by Utility Malaysia. We call it as a TMB, Tenaga Nasional Berhad in Malaysia. This TMB is a main utility lah, or can say that it's the only one utility in the Peninsular Malaysia that's supplying electricity to the whole Peninsular Malaysia. And my university, Universiti Tenaga Nasional, is a wholly owned university. So my research work also dealing quite substantial work with the utility part lah. So today I'm going to share on this topic, sustainable grid with the artificial intelligence and data analytics application. So this is my today content. So I'm going to share on 5 topics or subtopics: sustainable grids, big data analytics, artificial intelligence, grid with big data analytics and AI, and also sharing on Malaysia's utility aspiration. So first, I start with this sustainable grid introduction. So we have heard about the grid. Sustainable grid could be something new terms. Not many people use these terms. If you search online, there are only some people using these terms. But I try to describe these terms as a combination of below subcomponents. We have talking about the future grid of the future, the grid, how the grid will be in the future. So future grid, and also we're talking about the smart grid. The grid should be smart in the future. The grid should have an intelligence element. So we have a smart grid, and also we also have an efficient grid. We also talking about the self-healing grid, the grid that able to manage or have a certain level of intelligence that manage its own electricity or power flow inside the grid. Then flexible grid, the grid that able to take in renewable energy sources, change by time, change by requirement, and adapt to any load changes. Green grid, this is another grid that some people talking that using the renewable energy as a main grid. So the context of today, when I talk about this sustainable grid, it is a combinational elements of this grid. So let me give some background intro. So this is from one of the white paper talking about the energy or global energy scenario. So in 2020, so basically if you can see from here, we separate into 2 parts of the grid, transmission grid and also distribution grid. And not all utility we put it in such a way. Some utility will put it into three grids: generation, transmission, and distribution. But I think here mainly we focus on the transmission and the distribution. So in 2020, so basically the transmission grid, we are comprised of these power plants, conventional power plants, many thermal plants. Of course, there are some renewable energy plants also. And these power plants interconnected through the transmission towers, transmission grid, then supply into the large scale industries. They could be utilizing the high voltage level, 132 kV, 33 kV, etc. But again, voltage level also depending on the countries may vary. And also on the public transportation that utilizing a high voltage level. Then from the transmission grid, supply into the distribution grid, where big group of a customer or the people are at the distribution grid on the lower voltage level, where connect into the commercials and industries. Then in the distribution grid, also we have small energy resources or generators, which are the renewables, like rooftop solar, small scale solar, could be some area with small scale wind. So then this energy supply to the SMEs, small medium enterprise, and also to many buildings, many people in need for the energy. So as on the data level, basically in 2020, there are about 12 million of EVs. EVs we have now in the world, whole world, there are many EVs. We anticipate that the EVs will become more in the near future. Renewable energy sources, we have the 1.5 terawatt, and the heat pump demand is low at the 2020 at this moment. Then global share of a flexible load also low, less than 1%. And the battery storage is now emerging, but at this moment it's about 11 gigawatt. So this is a scenario as for now. And we do expect or anticipate that there will be the transformation of the global power system to, example, 2050. So at that moment, coupling of sectors will be high. Then electric vehicles will be tremendous in the quantity, like 836 million, okay, as compared to now what we have, because with the advancement of the batteries, with the technologies of the electric vehicles, the car price may become lower, become cheaper, more reliable, then the demand will increase, and also awareness of the environment factor may contribute to higher demand of these EVs. The renewable energy generation will increase also, maybe 10 times, become 12 terawatt. And heat pump demand will be high, increase also. Global share of a flexible load from just now below 1%, now become 8%. Battery storage also will grow, maybe 10 times, become 1.3 terawatt. So in terms of the architecture in the transmission grid and also distribution grid, what we can see the change will be the conventional power plants were maybe slowly replaced by these renewable energy plants in the big scale, like large solar power plant, and also the wind farm. Here diagram here showing that as a wind diagram, but more renewable energy sources were coming in, and conventional, especially the thermal power plant, may slowly reduce or even don't have in the future, or may migrate into the different like a biofuel kind of power plant. Then of course you still interconnect through the grid transmission towers. The plus here show that maybe I put my pointer. Okay, the plus here is showing that there will be increase in the quantity in terms of the transmission towers will increase. Then again, same, it will still go to the large scale industry, depending on the voltage level requirement, public transport, then go to distribution grid. As we can see from here, 2050s, the changes, it will be more significant or more obvious at the distribution grid, because they can see from here, there are many plus. Plus meaning that there is a change in the quantity in terms of increase. So commercial industry definitely will increase. Of course, this is as what we expect, 2050 as compared to now. There are more people in the world, more industry, more commercial business coming out. Their renewable energy sources will definitely increase, and now it's already in the increasing mode. So we will expect there will be a double plus, meaning that in terms of quantity, there will be double kind of increase. More renewable energy sources will be coming in, as renewable energy sources such as a solar cell, solar panel, solar BBs, low speed wind turbine, all this, the price will be going down, and then more people will opt to choose this kind of renewable energy sources by themselves, especially when the renewable energy sources generation cost, if it is lower than what we buy from the grid, then definitely more and more people is opt towards the greener kind of a solution. So renewable energy sources will increase. Then the other elements will come in, example like power to gas, hydrogens. So it may come into the picture as a supply, as intermediate supply for the energy. And for the buildings, it's also on the plus, definitely, with the more people in the world, we expect the buildings, demand, load, everything will be increased. And something more significantly will be in the grid in the future, in the distribution grid, is on these batteries. Batteries now is also emerging technologies where the grids now, in fact, looking at the different level of energy placement in the grid, before the meter, after the meter, in the house, etc. So batteries will become one of the elements appear in the grid when 2050, by the time of 2050s, battery will become something very common in the future. Of course, SME will become more, plus EVs will become more. So these are the trend, these are the transformation of a global power system that we anticipate in the near future, which is now already moving forward to that direction. So what makes the change of this grid migrate into the sustainable grid? We just now, the elements that we say, the future grid, the smart grid, flexible grid, and all kind of names for the grids. So there are actually four disruptive force that making the grid had to migrate. You have no choice. Okay, the force are there. There are four forces. Okay, we have a decarbonization, we have a decentralization, we have a deregulation, and also digitization. These are the four forces that appear now in the market, will push, will make the grid to evolve. You have no choice, and you have to evolve to the future grid or the sustainable grid in the future. So decarbonization. So now the world is very concerned about our global warming. So I think everybody also agree that our world is changing, the climate change, the environmental change, some place facing a different scenario as compared to years before, 100 years before. Certain place become very cold, certain place become very hot, sea level increase. So all this basically we can pinpoint to the climate change, can pinpoint to the global warming. And the cause of the global warming is the one of the causes is the CO2. So CO2 basically is generated for the this energy generation or energy utilization. So these two basically causing this CO2 be emitted and causing all these consequences to the world. So human, we know that this is the cause. So we have our effort to reduce, to decarbonize this factor that causing the world to change. So it is the process to reducing the carbon intensity, lowering the amount of a greenhouse gas emission produced by burning of the fossil fuels. So I just now, if you remember the diagram 2050, the diagram there show the source of the power plants. It could be from the renewable energy source, even in the transmission side. So the thermal source, thermal power plant may slowly reduce. Thermal power plant is using the fossil fuels, which generate the this greenhouse gas emission when generating the energy. So this will reduce. And also their effort also to decrease the CO2 output per unit of electricity generated. So this is also the effort that has been made. So producing the energy, but we try to reduce this CO2 emission at the same time. Such as CO2 capturing, CO2 utilization, or CO2 conversion into another form that can be environmental friendly. Some even using CO2 to generate the biogas, syngas, hydrogen, and so on. To meet global temperature standards set by the Paris Agreement, to meet the net zero emission targets sooner and in line with the Paris Accord. And the second force is the decentralization. So as compared to previous grid supply, it is more towards centralized, more towards single flow, upstream to downstream. So whatever energy supply that we get from downstream distribution, actually we get from the upstream transmission, the power plant. That is a one-way flow. But now, as the trend, we're moving towards is a decentralization. We will have more and more distributed energy resources coming into the grid. This is decentralization. We're not depending on one-way flow only from the upstream, but there could be downstream some small scale of energy resources that connected into the grid then can give us the energy supply. So this decentralization to be achieved through the distributed generation and storage in the decentralized grid architecture. So like a picture that I show here, the grid become interconnected downstream with the many connection. It's no more single flow from the upstream. Autonomous local microgrids where the energy is generated closer to where it is used. So as compared to old technology or old trend, energy is transmitted, could be far away, 100 kilometers away from the power plants, from the energy generation source. But the newer trend, as for today, today's world trend, we have more and more renewable energy sources, distributed energy resources coming in at the downstream and the distribution side, where it's closer to the load. In fact, like rooftop solar, it is, in fact, it's on the top of our roof. So the energy generated immediately can use by our load inside the house. This will save a lot of things, the transmission costs, and also the energy loss during transmission. So storage system to store excess energy produced by the distributed energy resources. So this is decentralization. Then the other force is the digitalization. So the whole world is moving into the digital world since the creation of computer in the around the World War II time. So things become digital. Now in this era, I think the digital almost connect everything in the world. That's why we have another topics here is big data, which is later. So making energy system more connected, intelligent, efficient, reliable, and sustainable. So by converting into the digital, there is another world called digital world, virtual world behind us, in front of us, not behind, can be. I mean, there is another world, virtual world. It's interconnected with the data, and this world is controlling many things. So in the future, all this grid will be interlinked from the generation until the distribution, until the customer or the prosumer, all will be interconnected in digitally. So it makes the system easy to be managed more efficient way and intelligent way. And also future grid can identify who needs the energy and deliver it at the right time, in the right place, at the lowest cost. So the grid is no more dumb like a previous grid or the old grid where it just supply, you take it, you open the tap, then the energy come out. I mean, you turn on the load, then the energy come out. It's not like that, but the grid will become more smart. They will know roughly what time more people need to use the load and where we can channel the power coming to the grid from where to supply to certain area, certain place. Because not all place need high load at a certain time, example, a certain amount of energy. So using the digital data, the system will able to do some forecast, will able to do some prediction in the more real-time mode to control the supply of the energy. Reducing operation and maintenance costs, improving power plant network efficiency, reducing unplanned outage, downtime, and extending the operation lifetime of asset. In fact, when the thing becomes digital, when there's outage, that very easy to be detected by the system itself. And then later I will share also through the workforce management, then we can dispatch the right people nearest and the best skill set people, competent people to solve the outage or the breakdown at the shortest time. However, creating new security and privacy risks, yeah, this one I think is common to everybody. When the things become digital, connected in the digital world, that will, I mean, that gives a chance for people to tap in, to hack in, and do some, I mean, unwanted things inside. So this create another risk. And this digitization changing the markets, business, and employment. Then last force, deregulation. This global energy demand increasing need the new source of funding from the public and private sector for energy markets. As compared to previous, the trend is changed. last time only big players that can do power plant, generation plants, because it need a lot of capital to set up. It's hundreds of millions to set up the power plant. But with this advancement of the technology, like just now what I mentioned, like rooftop solar, the initial capital to start is very low. Almost everybody is able to invest. So that's why the deregulation coming into the picture, which allow people to generate energy from the big source to the medium source to the small source. We deregulated it, then everybody can come into the picture. So more players into the market, that make the market also, energy market, more competitive, and the price is more competitive or reasonable for the consumers. Asia market, currently Europe Union is more leading in this deregulation of energy, but the Asia market soon or may follow suit or will follow suit. In fact, Singapore is already, Vietnam and Malaysia is in the plan. We are now working on how to moving forward to this deregulation of the energy. So beside the 4 disruptive force, there are also 4 disruptive technologies coming into the grid, which make the grids have to change. You have no way not to change. It's the renewable energy sources coming in, renewable energy technologies coming in, more and more renewable energy technologies coming in that make the people go and harvest the energy from the ambient, energy from the nature, rather than we have to get from the fossil fuel. So renewable energy technology is one of the disruptive. We call it disruptive because it made the change to the existing grid, but we can see it in the other positive side, which we change the grid to the better one in the future. And EV coming into the grid, EV is a very different kind of animals in the grid, because you will take out the energy very fast in a short while from the grid. So the grid had to be prepared to adapt this kind of animals into the grid. So EVs, where the EVs is coming out in the big quantity in the near future, so the grid had to change, had to migrate, had to be more intelligent, and to be more flexible. Then also energy efficiency devices. So meanwhile, when there is one side keep on increase on the energy demand, there is one side, the technology will make the energy device become more and more efficient. So try to bring down the energy consumption. So this will become something like one side going out, the other side going down, to balance the grid. And energy storage, as just now mentioned, it is something that very important in the grid future. It can be worked as like buffering on the energy supply and demand. So consequence of these 4 disruptive technologies and also 4 disruptive force, so the grid can become something different in the future, where you have a utility scale kind of storage. From the utility side, they can make also the storage, which we name it as a virtual power plant. The power plant is no more conventional. You see as a coal-fired power plant or gas-fired power plant, but the power plant itself is a big energy storage. The energy storage can be single one or can be a few one interconnect together. You will just take the energy being charged to the storage when it is low peak time. Then when less people consume energy, then it just get the charge stored into the battery storage. When it is high load time, then beside the supply from the conventional plants, this storage will act as a virtual plant to give out the energy, to plus the energy into the grid, so that the demand, the load demand can be fulfilled. This also make some changes in the landscape, because if in the conventional way, when the load is increasing more than the capacity that can meet by the plant, we have no choice but to make new plant again. So utility scale storage can make the change in the landscape. Then also we have a distribution substation automation based on the digitalization. Then we have a local wind farm. This is all on the microgrids level. So we have this local solar farm, EV, industry offices, and also automation inside the home. So these are the things that will be coming into the sustainable grid in the very near future. So these are the 4 elements in the sustainable grid landscape, where enabling technology is coming into the landscape, system operation side, market demands, and also this business model. I will explain it a little bit more detail in the following slide. So in terms of the system operation, so there will be more collaboration between the transmission and the distribution system operator. As conventional methods, basically transmission work at the transmission side, distribution work at the distribution side. In some country, that is actually belongs to different company. So they do not need much collaboration as long as the grid is connected. But in the future, in the near future, all this collaboration between the transmission and the distribution will be more intelligently connected. More data will be shared for this control, for this management to make the supply to be more flexible and more efficient. Then managing uncertainty, advanced prediction of different renewable power generation, storage as a buffer. Just now I mentioned the energy storage as a buffer, and prediction. The prediction, especially when there's a large scale, like a large scale solar farm, then that is very depending on the energy and on the weather change, the energy produced also change. So we will need kind of predictions tools that are able to predict the weather for the next 1 hour, the weather for tomorrow, so they can more well plan on the energy dispatch or supply. And currently, there are already some company working on that. Like a Malaysia scenario, we basically many are still buying from China the solar PV, and this some prediction of tools are also come together when purchased or when set up on this large scale solar farm. Grid reinforcement deferral. So there are virtual power lines inside the grid, as shown from this photo here. Previously, power generation to the grid is just one-way connection, but now we have a storage in between to do this buffering. And it works also as a virtual power lines, where usually it can be no inside. I mean, it can be directly supplied, or sometimes it can go to this where is no direct supply. This line appear when there is charging and discharging from the storage. So we have a supply side storage and also demand side storage as from the system operation side. Then in terms of enabling technology, so we have utility scale batteries, behind the meter batteries. So batteries is something that will be very common in the future. So for academic researchers, maybe you may consider to do some research into the batteries. Then EVs, smart charging, renewable power to heat, renewable power to hydrogen. Hydrogen is also one of the renewable energy source they're picking out. Internet of Things, artificial intelligence with big data, which is today also we will share, I mean, in this keynote, blockchain, renewable mini grids. So business model, then there'll be aggregators coming in to enable smooth integration of the distributed energy resource into the power system, which can contribute to the system flexibility, because aggregator is the one that manage. So with the aggregator coming in, so it can manage the energy supply more smartly and make the system more flexible. Peer-to-peer electricity trading. So this is also something that emerging. The purchasing of the energy is no more from the big power producer, but in fact, if my house have a solar supply, solar energy supply or wind energy supply, and I have a surplus, I can sell to nearby people in the grid. So peer-to-peer trading. Then energy as a service. So energy is no more just supplying energy itself. Of course, the main thing is still energy, but the energy itself can have a subsequent business that we can generate. Example like behind meter service, demand management, energy storage, energy exchange, energy saving, smart home automation, and so on. So these are the things that can be, I mean, ancillary services that we can produce as a business model in the future grid or sustainable grid. They are unlocking energy system flexibility. So market design, so market will change also in terms of the classification, in terms of clustering. So depending on the time granularity, based on the time, based on the space, so we may segmentize the market. And also depending on the ancillary service required, so we may, I mean, change the customer group, grouping into different group, who is a customer for this category, which need this kind of service. So redesigning capacity markets, regional markets, time of use tariff, market integration of distributed energy resources, and net billing schemes. These are the things that will come in then to make the market segmentized or classified into the different region. So basically, I think this one I may skip. Basically, is reflect the same thing. Previously, from the top diagram, energy flow, this is the traditional one, is one way. Money flow is the other way. But with the new paradigm of this electricity supply chain, so energy flow can be bidirectional, and in fact, the money flow can be bidirectional also. Not saying that it's only one way. So this is a transformation to the sustainable grid in the future. Like the grid landscape and the architecture may change. So next, I move to this big data analytics. So last time we don't have many digital data, especially the data here we're referring to the digital data, not the physical data on paper, but the digital data. Starting from the creation of the computer, I think around the World War II time. So computer now become more and more common. Now it's not only computer, many things actually is digital. So sensors coming in the big quantities. So all this is the data in the digital form. So previously maybe the data is like Rex, but now the data is becoming like elephant, big elephant. So this is one diagram. How big is the data now? This is something that I take, from the online. So just give us some glance. How big is the data now that we have in the world? So in the 2020, every 1 minute of the day, every 1 minute, this is only 1 minute. Whatever figure that you see now is only for 1 minute. So 1 minute, Zoom. This conference is in Zoom, right? 1 minute, Zoom hosts 208,333 participants in meetings. So inclusive today, because this is a statistic, this is average out. So every minute there are so many people inside the Zoom. But in terms of data, there is more because the data I keep on streaming. The moment I broadcast my video to your site, to the conference site, there are so many data being sent within seconds, within milliseconds. Okay, so you can imagine how many data being sent or generated. So in nowadays, this is only Zoom. We have other things, Netflix. Okay, Netflix, 1 minute, we have 404,444 hours of video inside the Netflix streaming. So this is very huge data. So the data bus at the back is really is very busy every day. In fact, never sleep. Humans sleep, but the data at the back never sleep. So another example like a Facebook. I'm not sure how many people using Facebook, but Facebook users share 150,000 kind of messages. This is messages, not the data. Messages in 1 minute. So the data behind is very, very big, and a lot of data coming today and not future. Future more. Okay, today, this is for today. So what are the benefits of this data warehouse or this big data analytics? It enables historical insight. If we collect all this data, then we can, from the data, we can very easy to see the trending, what happened to previous to now, and also we can predict for the future. Enhance conformity and quality of data. We can also check for the data quality, boost efficiency. Based on data, we can see how we can make better in terms of efficiency, increase the power and speed of the data analytics, drive revenue. In fact, from data analytics, we can drive the revenue. In our context today, we're talking about the energy. Energy, yes, we can increase revenue from the data analytics itself. And high scalability that interoperates with the on-premise and cloud. So this one now, the data, previous data is every company, you need to host your data somewhere in the physical server inside your company. But with the technology advancement, we can eliminate that part. In fact, they are cloud. They're able to store our data. Of course, we need to pay. But the good thing is we do not need to maintain our physical server in our company. So boost data security, higher query performance insight, and major competitive advantage. These are the 10 benefits that we get. So this is on the types of data analytics. What are the types of the data analytics? Here is showing 4 types: descriptive, diagnostic, predictive, and prescriptive. So these 4 types of data analytics, you have a different value. So seeing from here, at the y-axis, so when from the bottom go to the out, it increase the value of the data analytics to the company. And for the x-axis, from the left to the right, it increase the complexity of the analysis. So we can see from here, the moment we go higher out, basically it's more complex to analyze, but it bring more value to the business or the company. So descriptive is basically from the data, we will know what's happening. Example, in the utility context, we know, oh, where is the tripping? Where blackout now? Where have a shutdown now? Where have an outage now? Then next, from the analytics, from the data, then we're able to correlate what is happening, why it is happening. Okay. Then next, we can predict. Okay. Not only know why it is happening, what is likely to happen also. Based on historical last few days data, based on the last few months data, very likely the breakdown or the outage time will getting shorter and shorter and finally totally out. So this, I mean, from the data we can predict. I think this is very easy to be understood from the data. We see the outage. If the outage trend frequency become more, of course we can predict it will become more and a faster, shorter time in the future. Then next, from the data also we can see what should we do now. Is there any way that we can do recommended action? So seeing from the trend example like this equipment in the next 3 months time, it will create a lot of troubles. It will make our example like SIE going down below our target. Then we must do something now. We must change. We must procure the equipment to change, or we must have to do something. So these are the things. So through the data analytics, in fact, we can get a lot of information and help for the industry, help for the energy utilities. These are the 5 V's of the big data. So we have volumes, we have value, we have velocity, variety, and the velocity. Velocity is accuracy. So big data basically it comprises of these 5 elements. Volume, I think definitely every people know. Big data, talking about big data is a big volume. Volume, very big. Value, yes, there is very big value inside. Only thing is how can we dig the value out from this big data? Usually from the raw data, we can't dig the value. We need to do a lot of process analytics, correct, then the value will emerge. Then velocity. When we talk about big data, speed of data is tremendous. Data coming in, no stop, as what we show in the picture there. Every minute, data keep on coming in. Variety, of course, data also in any company, there are many types of data. Just like a power utility, we have asset data. Asset talking about transformer, talking about cable, talking circuit breaker, talking about meters. There are many different types of data. And also we have a human data, human capital data, human resource data. Then also we have the other things like weather data. So we need all this data to work together. So there are variety of data. And veracity. So this is usually at this moment, our big data we face the big challenge is at the veracity here, which is accuracy of the data. I think most of the countries still in the improving stages to make the data as accurate as possible. So now most of the places we have big data, big amount of data, but how good is the data? How accurate is the data? That is always a question, because that will influence whatever analytics after that. So veracity, the accuracy of the data is one of the very important elements of this big data. And this is a life cycle of data analytics. I will just briefly explain. First, in any industry, you need to identify what is the business. As for today's context, my context, I was mentioned on the energy utility. Then we had to identify what are the data inside. As I mentioned to you, there are many data, transformer data, cables data, circuit breaker data, smart meter data, even human resource data, many data inside. So then we had to see how to take the data out. So most of the data is inside servers here, independent server, maybe centralized server, maybe in this office, maybe in the centralized ICT department and so on. So how can we get the data? So we have to do filtering, acquisition, then extraction, extract the data out. Then we have to do validation, validate the data. Not all the data just take out is correct one. As I mentioned, the veracity of the data is still a challenge in many places in the world, in the industry. We have a lot of data, but how good, how accurate is the data is the question. So do the data cleansing, remove the noise, outliers, then the data aggregation, presentation, then analytics, then visualization. So whatever that we analyze, this is still in the back end, maybe in the text form. And this is a visualization, how to present it in the graph, in the report form to the people. Then next is the utilization of this analysis result. So whatever that being presented, so we know already what is the trending. Some is a market growth, example like what is the trend of renewable energy demand in Malaysia or in Sri Lanka, example. So if we see the trend is like that, so what shall we do now? That means more people will coming in the very near future. Besides, on the grid level, we have to prepare. Is there any business that we can do? Since there are more people now coming as a preferred renewable energy sources, can we take solar PV as also one of the business inside the company, or the wind, example, also storage? So this is big data security. Then we talk about big data. Of course, it brings good values to the company, but also it gives another issue which is on the data security side. So then we need to monitor the security, traffic analysis. Is there anything unknown people, unwanted people suddenly coming to the system? And in fact, not only from outsiders, also insiders. Is there any insiders that have can reach on this data that he or she not supposed to access to? Then how to hunt this threat, then do data management and data privacy. And these are the few elements of data, big data security that we need to consider in everywhere. And this is about the big data tools. So it depending on preference, most of these tools have a common features, common function, but you have a preference. Some people may like this one more, like the one more. Like in my utility, we use Cloudera, we use Hadoop, we also use Apache Spark. These are the things that we use. But like Microsoft Azure, also one of the very famous one, many people using Kafka. These are the things also. I think in some countries, some people may use more on this. And Rapid Miner, my university using big Rapid Miner. So in my experience, we are using this Cloudera, Spark, and Hadoop, and a Rapid Miner. So these are a few more famous or common tools on the big data analytics. And this is the components of the big data architecture. I think due to time constraint, I don't go into the details on this. So this diagram basically shows one thing. Big data is at the first layer. We have more things now. You see public data, sensor data, structured data, unstructured data, many data. Big data is here. But when we do analytics, what we do now is we are actually making the volume less and less because we dig out the information that we need. We correct, then we filter. We only extract out the important information that is useful for us. So as you can see from here, it decreasing volume of content when we do data analytics. Okay. And at the same time, increase the quality of the content. So we do refinement, we do structuring and linking, and then we do synthesis and enhancement. Finally, at the end, we want to get the benefit for the industry that we are in. Cost reduction, like how to make our energy cost per kilowatt cheaper from generation, transmission, until the distribution. Then faster and better decision making for the system. Make sure the system is always reliable, always up and no down. New products and services from here that like just mentioned. If we see the trend of people moving towards some place, what shall we do? Is there any business that we can do to cater the potential of the value? So big data application. So I think this one no need to mention in very details. I think everybody also know that big data can be applied almost everywhere. Of course, education, and this is my university photo. Manufacturing, governments, healthcare, finance, transportation, energy and utility. Today's topic is on this energy and utility. So big data can be used anywhere, but in order to do this, the process is like just now. We have to identify the business first. then we have to identify what are the data inside, then we have to identify where are the source inside. So step by step we do. Finally, we pick up the data and the value generated from the data. But this process is not easy. I myself also involved in this data analytics for my utility company for many years. In fact, still very challenging. So next, I move to the artificial intelligence. So there are many artificial intelligence. Artificial intelligence is a broad kind of scope. It actually just saying that it's mimicking human behavior as an intelligence factor. But when we use it in the machine, basically we are talking about the machine learning algorithm. There can be supervised learning, unsupervised learning, reinforced learning, deep learning, and so on. I think there will be another keynote talking about deep learning. So you can focus on that later. So, and in terms of the methods, there are many methods: classification, regression, clustering, dimensionality reduction, multiple hidden layers, convolutional neural networks, recurrent neural networks. In this detailed example on this, I think if you need, I can share this information later because I see my time is not so much, so I have to go faster a little bit. So these are the type, okay, as I mentioned, we have different type of machine learning algorithm used for different purpose. Not all can be used for the same purpose. Classification type of methods basically used to classify, example like a fault, equipment fault. This is normal, this is not normal. This one faulty, this one not faulty, example. So this is classification. So example like this, random forest classifier, nearest neighbor classifier, extreme machine learning, support vector machine, multi-layer perspectron classifier. These are the common one, famous one that you can use for the classification to just determine whether okay, not okay, good, no good, fault, not faulty, normal, or faulty. Example like that. Next is a regression. Regression is quite numbers of people now putting effort into this because we actually go for the prediction, go for the forecasting. Example like in the utility, we need this to predict the weather. Okay, we need this to know whether the equipment may break down or not in the near future. We need this also to see whether is there any person possible to make fraud into our energy supply, meaning that's electricity. So under this regression models, so SBM regression, Gaussian process, this MLR, multiple linear regression, and logistic regression. Basically, if you see the words of the regression, it actually show this kind of graph from the historical until future. Okay, so we can see how the trend going on. Clustering. Just now we have a classification. Classification basically is to divide which class you are in. Clustering meaning that we have more type. We want to group the data into different group. So we have a clustering. So the K-means algorithm is the most widely used. Fuzzy C-means and this self-organizing map. These are a few clustering type AI which is commonly used. And also reinforcement learning methods, which the method itself can be reinforced by learning itself. Okay, keep on repeating feedback. And deep type AI. Okay, so it is something very hot topic. We have another keynote on this, so I will skip this part. So next is Greek with the BDA, Big Data Analytics, and also AI. So this is just in a nutshell what can have inside the grid. So we have a power generation, we have a power distribution, and also we have a power consumption. So these are the few main elements inside the grid. So of course, the energy we have to supply from the power generation go to distribution, then go to the consumption. This is conventional. But nowadays, the grid and also towards the future, one part with the dashed line here will be more and more important, which the data, because we're not only sending the energy itself, but we also need to send the data together with the energy. But I don't mean the data inside the energy, which it may be happen in the future also. But energy one path and data is another path, where there are many information we need to send together from this generation to the distribution and to the consumption. And there are many things that we can do. Even at the generation side, there are many data analytics work can do. Distribution side, many data analytics can do, and until the consumption, which is at the end side. Okay, like energy storage, energy management, control, and so on. So these are the data analytics of the grid components. So these are the example what can be done. So senior analytics, senior sensor signals from the generation side. There are many sensor signals. At the distribution side also, there are many sensors inside. Substation waveform, okay, and also this is line sensors. So event, we can do the detection, classification, filtering, and correlation. These are the big data analytics part that can do with this event. One of the event example like advanced metering infrastructure. They're coming back not only the profile, the energy consumption profile of the people, but also coming back a lot with the events. What happened at site? Example like meter cover open. Example like one phase cut off or drop. So all these actually will come back sooner. So and all these things coming back sooner. Then what should we do with all these events? So we need the data analytics at the back to analyze, to collect, to extract this data, and then to link out to somewhere. Where is it something wrong outside the meter? Is it anybody now plan to steal the electricity inside, or somebody doing something onto the meter? So all this actually we can extract the information out from all these analytics. Then step analytics, example, what is the grid condition now, off, on, and also the system condition. Then this is on the operation side. Operation also can know how effective. Example, like give a task, give a job to the people, but how long time it come back, how long time it finish, what is the time? So is it getting longer and longer, or getting shorter and shorter? And is it somebody short, somebody long? Why? Is it somebody long one? Is it not competent enough? So what is the matter? What is the issue? So from here we can do some analytics. Then from consumer side also same. What is the preference? How is the usage? We now this advanced metering infrastructure. Basically, utility side will know also, roughly will know, is there anybody at home? Because they will see the trend, every half an hour trend. The machine will know. When we write the program inside, we will know, okay, these people, maybe now no more people in the house. And in fact, for fraud also, we can see also, when there's people all coming back at night, electricity out, but somebody going down. Why the person going down? If always like that, there's something unusual, right? If one day going down, maybe the day he outstation, but every day at night going down, is it certain timer to control to bypass the energy supply? Example. So from all this profile, from this analytics, especially we will know what happened at the customer side. So this one, I think I already briefly mentioned in the AMI just now, what we can do. We can collect many data coming back through the AMI. AMI can put in a many place. Beside the customer side, we also can put at our substation side. We also can put at our grid side. So we can monitor, we can match all the data together. Then this is smart meter analytics. So what are the things that we can do? So, and smart meter analytics, basically we can do it in the cloud computing mode. We can do it in the fog computing mode, because you need a big processing power to do this. Later, one of the slide, the last slide, I show what we do. The data coming back is very huge. We need a very big processing power to do this processing. So this is on the communication network topology. I think I will skip this one. Grid domains, okay, maybe basically, okay, they are components inside the grids. Okay, these are the area that we can do, we can incorporate data analytics and also AI. Okay, grid operation, substation, and also on these consumer networks. Okay, in very detail on this, what are the AIs that can be used for what purpose? These are some suggestion or some previous work people have made. You can refer to more details from this journal, State of Arts Artificial Intelligence Techniques for Distributed Smart Grids review. So it is journal, so you may get from more details from the journal. So these are the AI types being used for this application. Okay, DR integration, load management, power flow optimization, generation forecasting, and so on. Same for the rest. This is a different level, like distributed grid and smart prosumers. So these are all the AIs that some people have been doing on this area. And this is similar. These are the AIs for different application inside the grid. So next, I move to the Malaysia utilities aspiration. So this is more specifically on the Malaysia scenario. So in Malaysia, we have a plan to make our utility a smarter grid in the future, which is 2025. We put it as a Smart Utility Plan 2025 or SU 2025. And we are targeting on the five focus or five elements, which is asset management, work management, grid operation, energy management, and also on the customer management. These are the five five area that we are expecting good improvement or incorporating on the big data and also the AI to make the system better and more ready for the future. So we are working on the resource optimization when the data-driven asset strategies will be outlined. So based on the data, how we can outline on this resource management uh, and also connected and smart workers. The workers is a more real time. We can know where are they and we can assign to job to them more dynamically, more real time, but it's not simply assigned. As for current, I'm not sure everywhere in the country how, but previously in Malaysia, when we assign the job to the workers, so we just see, okay, we can remotely assign the job to the workers, but it's more towards we just assign to a certain person. But soon we will be more intelligent kind of mode. We have a more interaction where we will know the people, where are they? Let's say we have a one outage. So now we can check who are the people nearby there can be fastest respond to the outage to handle the outage. And not only that, we also can know, we also have the data to know what is his repairing time previously and what are the competency skill set that he have from the HR. So all this data we can link. And let's say it's a 5% around the area, and we can easily see this is the top ranked person dispatch they at the fastest to solve the matter in the fastest way. So this is what we anticipate connected in the smart workers utilizing data and also AI. Self-healing grid, the grid become with the smart elements, they know how to manage the energy flow if there is something happen. So energy efficiency and also the customer empowerment. So in future, people in Malaysia may allow to choose what kind of energy supply they prefer, conventional one or renewable energy supply, which of course will be maybe more expensive at this moment. But for the greener world, so willing to pay for the higher price, especially some industry. My understanding that even opt for 100% renewable energy supply, even though with the higher cost, because they want to be a green rated and they want to be, contribute to have a good impression of the company and also to get the international kind of business recognition. So this is in the geographical map what we hope to achieve in the 5 years time in Malaysia. This is Peninsular Malaysia. Malaysia has two parts. There is another East Malaysia, which is not under here. This is West Malaysia, Peninsular Malaysia. Green color show the majority of grid, which are moving forward to the future grid or sustainable grid. Can see from here, there are two states we expect will be green, which is Malacca states and also Selangor, which is our capital states. The rest will be yellow, which is about the middle range, 3. And the Johor, our southern area, will be between green and yellow. So something like that. So as I mentioned, we have a 5 focus for us to make it more smart, more intelligence, and better in the near future 5. So these are the things that we're going to do. As we can see from here, number 2, AI assisted diagnostics procedure. So AI elements were coming in. So number 3 also saying AI-based control decision. The rest, there are many things actually depending on the data also. Number 5, artificial intelligence-based customer and agent interaction. So you can see from here, AI with the grid is very close. Data analytics and the grids very close in the sustainable grid or in the future grid. So these are the elements that will incorporate what are the smart things. I think I don't go to details. So many smart elements will be incorporated into the grids. And this is advanced data analytics for the utility grids. So first, of course, starting from the data collection from all the sensors, the analytics. Then at the end, this is our aim. We want to do maintenance, and example like reliability, condition maintenance. So this is one of the aim of utility lah. We can identify the reliability of the asset. So this one, I think I can skip. It basically reflect the similar thing, which we have 5 focus here. And what are we going to do? So example, like big data analytics on the customer management and experience, IoT, sensors, AI on this asset management, etc. And then the other interesting thing is this energy management, AI and blockchain, where we talk about this peer-to-peer trading. Blockchain is one of the important technology that will be implemented. So this one, so consequent for this 4D, so Malaysia is moving forward lah. Then we do the value creation on this security, efficiency, value brings experience into the smart utility in the 2025, which is our aspiration. With these new things incorporated, on the right is a new thing. So now we see many tick, 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 tick. I didn't go to the details. These are the new things with the new smart elements incorporated. So this one, I think I won't go to very details also. We outline the plans, how we can reach our aspiration in the 5 years time. So step 1, step 2, step 3, step 4, oops, step 5. So starting from the functioning, how we can improve, then do the integrating and optimizing. At the end, we want to have a better response optimization, self-healing grids, connected and smart workers, energy efficiency, and empowered customers. So this is our aspiration towards the smarter, sustainable grid in the future with the AI, with the data analytics. And just now I mentioned to you, I share one of the works that I do with the utility. So this AMI data on the 2021 August. Events data coming in. This is 1 month data. We have 174 million data coming in. Then profile data is this is 6,643 million data coming in. So we have a huge data set for us to work. But once we correct, we process everything, then we can do on this non-technical loss detection, asset condition monitoring, breakdown areas identification, and also breakdown equipment and cost identification. So the result is something like this, the text reporting, and also graphical visualization. So this is an example of the graphical application. So it will show where is the breakout or outage now. And then also can pinpoint until the other level, which connection, which cable likely have this issue now, and what could be the cost. Then we can dispatch people to the grid, then do the rectification work inside. Okay, that's all for my keynote address today morning. Hope you follow through all my presentation. So I hand over back to Mr. MC or Chairman.
We now move on to the next event of the day, the paper presentation sessions. I kindly request all authors to log into your respective conference rooms before 9:15 a.m. The links are available in the program book. Afterwards, we will commence our next keynote address in 2 hours' time. I would like to invite you all to join us for the next keynote speech at 11 a.m. in the same meeting room. Thank you. Have a pleasant day.
Thank you, everybody. Thank you.